E equals mc squared, space-time, relativity. We've all heard of these prolific concepts, but what do they actually mean? What do they imply for everyday people? Well, I'm here to explain these things and also talk about their founder, Albert Einstein. First, a little bit about the man himself. Albert Einstein was born in 1879 in Germany and lived various places in Europe until 1933 when Hitler came into power. After reading a little bit about him in his bio by Wyszynski, I feel like I know a lot about Albert Einstein. He had a very prolific academic career, and in 1905 he published 3 papers that changed the world forever. 10 years later, he published a paper on general relativity, and 2 years later, in 1917, he published his first paper on early quantum mechanics. So first for the papers published in 1905, the first and perhaps one of the most important was special relativity. Special relativity is the idea that everything is relative except the speed of light, which is 300 million meters per second, or 7.5 circumferences per second. This has a few crazy implications. The first of which is length, time, and mass are all relative. So these things change depending on how fast you're going. Time has been depicted in Hollywood films many times. The time dilation, if you guys have seen Interstellar, there's that one really cool scene when they're on the planet and then like a few hours, a few decades on Earth. But that's a completely real thing that's been tested. And length and mass will also change depending on how fast you're going. A few other implications of this is E equals mc squared, which is the energy mass equivalence. So because when you're going faster, you have more mass, these two things are intrinsically related. Also because of special relativity, we know a cosmic speed limit. So nothing is ever going to be able to go faster than the speed of light, because at that point you would have infinite mass. And also time doesn't really exist when you're going at the speed of light, so at that point you can't go any faster. The next paper he published in 1905 was on Brownian motion. Brownian motion was something that had been observed for a few decades, but no one had come up with an explanation. It was basically the idea that when a small particle moves through liquid, it bounces around in a random motion that can't be explained. Einstein developed a theory that explained this based on math and whatnot. And basically, the significance is that it proved everything around us is made of small indivisible particles, atoms and molecules. And people had theorized this since the ancient Greeks, but Einstein was the first to provide mathematical proof. The last, and I would think the most important paper he published in 1905 was on the photoelectric effect. The photoelectric effect is the idea that some metals release electrons in the presence of light. And this again has a few revolutionary consequences. The first is that light comes in discrete packets called quanta, which some people might have heard light as a wave, and this contradicts that. But in reality, light is a wave and a particle. It is wave-particle duality. And the photoelectric effect, although it may seem limited in how much it actually means to us, opened the gate for quantum mechanics, which would change the world forever and make our quality of life possible. And I'll talk about quantum mechanics in a bit. Then 10 years later, Einstein published his most famous paper on general relativity. And as I explained with special relativity, time and space are intrinsically related. And with general relativity, he broadened that idea to more than just people moving at the speed of light, but to the entire universe. And he basically declared that the entire universe is made of the fabric of space-time, which doesn't really make sense, but you just have to accept it. And that a few implications of that are that gravity are caused by bends in space-time. And this has basically allowed us to make predictions about gravity and speed that are much more accurate than normal and make space travel and things like global positioning satellites possible. And this I learned in the Journal of Relativity. So Einstein had a very interesting relationship with quantum mechanics. As I said before, in 1917, he published an early paper on quantum mechanics, but as the field developed, it sort of left him. And now when modern quantum mechanics became accepted by scientists around the world, Einstein was kind of in disbelief and he couldn't accept it, mostly for a few of the tricky aspects of quantum mechanics. The first is that two particles could be in contradictory states, two different places at the same time, two different qualities at the same time that shouldn't exist. And also certain things are completely random and unobservable. So Einstein went through his whole life trying to find an alternative to this idea of quantum mechanics, but basically know that now that that Einstein was wrong about that one thing, and our current model of quantum mechanics, as hard as it is to believe, is true. And it was because of quantum mechanics that we have the computer chip and other key technological innovations that without which we would have totally different lives. So those are Einstein's theories, and then a little bit on the influence he had after he was done with all his scientific work. So in 1913, he found himself in the United States when Hitler came to power, and then for obvious reasons, he was Jewish, so he didn't move back to Europe. And basically in the United States, he then became more of like a prolific political leader. And one of the things he did was he sent a letter to FDR persuading him to build a nuclear bomb, because, and his reasoning was that if the United States built it before the Nazis did, then you could prevent, nuclear Armageddon. Albert Einstein was also a very influential Zionist leader, meaning that he was a leader in getting Israel and giving Israel to the Jewish people. And as a result, they actually offered him the presidency of Israel in the 50s when it became a state, although he declined, saying that he didn't really have enough political experience. So our basic understanding of the universe rests on two pillars, which is general relativity and quantum mechanics. General relativity governs the large things of the universe, orbiting planets, traveling between solar systems. Quantum mechanics is the small things, quarks and electrons that make up the atom. And Einstein, without doubt, is the single founder of general relativity. And for quantum mechanics, his ideas would make them possible even if he did fight them along the way. So it's because of Albert Einstein that we can look up into the universe at the stars at night and understand why the stars are the way they are, instead of coming up with random stories that have no backing. So even if understanding the universe isn't enough to convince you that Einstein and his theories are significant, you can thank your iPhone, your computer, your traveling in airplanes, your GPS, all of those things are thanks to Einstein's theories.